You could have the fastest car on the grid, maybe even the perfect setup on paper. But if you can't read the data, you will never, ever unlock its ultimate potential. So this is where it gets interesting. The gap between what the car is actually doing and what the driver feels it's doing is something you hear all the time in the pit lane. The driver tells the feeling, but the data tells the truth. And the person whose entire job is to be the translator, the bridge between these two worlds, well, that's the race engineer. So how exactly do they do it? Well, that's what we're going to break down right now. First, we'll learn the engineer's two languages. Then, we'll dive into how to read the story the data is telling us, and just as important, how to decode the driver's feelings. After that, we'll see how to connect fact with feeling. And finally, we'll look at the real-world workflow. All right, first up, the engineer's two languages. This is all about translating a feeling into a cold, hard fact. So what even is data in this world? I mean, when an engineer fires up their software like WinDarab, it's not just a bunch of numbers on a screen. The thing you really need to get is this. Data is the recorded behavior of the car. It's what the machine actually did, completely separate from what the driver thought it did.
Let me give you a perfect example. A driver might swear they were at 100% throttle, and yeah, the data could confirm the pedal was slammed to the floor. But did that mean the car was accelerating as fast as possible? Not always. The data reveals the hidden truth. It can show us a tiny bit of wheel spin or the traction control system secretly cutting engine power, things the driver might not even feel.
So if data is the car's true story, how the heck do we read it? That's our next step, finding that hidden narrative inside all those numbers. Now, a modern race car logs hundreds of data channels. Seriously, you can get lost in it. So the trick is to start with what we call the core channels. We're talking speed, throttle position, brake pressure, steering angle, the individual wheel speeds to see if anything is locking up or spinning, and of course, which gear the car is in. This gives you a really powerful high-level snapshot to start with. Once you've got those core channels locked in, you can break down any corner into three simple phases. On corner entry, we're looking at brake pressure, how hard and deep is the driver braking, and just as important, the timing of the brake release. In the mid-corner, it's all about minimum speed, or Vmin, and the steering angle. And finally, on exit, we're focused on when and how smoothly the driver gets back on the throttle and how the car puts that power down. Okay, let's put this into practice with a classic problem, the lazy exit. The driver comes on the radio, says the car feels sluggish coming out of a corner. He's absolutely sure he's at 100% throttle, but the car just isn't pulling. So what's the data really telling us?
Now, while the data trace gives us the final word, the solution is often right here, on the steering wheel and dash. Even with the throttle at 100%, other data channels might show the real culprit. Maybe the traction control setting, the TC cut, is way too aggressive in killing the power. Or they might be on the wrong pedal map, which changes how the engine responds. The point is, the fix is often just a couple of clicks, not some huge mechanical change.
You know, one of the most powerful tools in an engineer's toolkit is the data overlay. By layering the graph from a driver's best lap right on top of another lap, they can instantly see these tiny but crucial differences. We're talking about braking just a meter later or getting on the throttle a fraction of a second earlier. These are the little gains that, when you add them all up, make the difference between pole position and starting mid-pack. But look, data is only half the story. Now we have to shift gears and talk about the engineer's second language, decoding the driver's feelings. And trust me, this is an art form. A driver might jump out of the car and just say, the car has understeer. Okay, that's not super helpful. A great engineer is like a detective. They have to dig deeper. Where did it happen? Was it on corner entry, in the middle, or on exit? Was it a high-speed or low-speed corner? And what were you doing with your feet, braking, coasting, or accelerating? The answer to each of those questions points to a totally different fix. And this is how that specific feedback gets translated directly into technical solutions. If the driver says entry understeer, the engineer's mind immediately goes to aero balance, things like ride height. If it's mid-corner understeer, they start thinking about mechanical balance, the physical setup like springs and anti-roll bars. And exit understeer? That points them toward the differential settings or how aggressively the engine is delivering power. So, let's say the driver's feedback and the data both scream mid-corner understeer. The engineer doesn't just start guessing. Nope, they go right to the car's setup manual, just like this page, to analyze the different spring stiffness options and make an informed change. It's a very methodical process. Okay, so we've got the hard data from the car, and we've got the subjective feeling from the driver. Now comes the critical part, connecting the two to make the decision that really matters. So, The data's been downloaded. The driver's feedback has been heard and decoded. This leads to the ultimate question that every single race engineer faces after a run. Who do we fix, the car or the driver? And the answer is always found by comparing the two languages. If the data shows the driver's inputs are inconsistent, maybe a bit rough or just timed poorly, well, that's the driver problem. The solution is coaching, sitting down with them and looking at the data together. But if the data shows the driver is being smooth and consistent, but the car has clearly hit a wall, like the steering is at full lock but the car just won't turn anymore, then it's a car problem. And that means a setup change is needed. And this leads us to the absolute #1 golden rule of race engineering. You never, and I mean never, set up the car to compensate for a driver's mistake. You have to fix the root cause. Trying to put a Band-Aid on a driver's mistake with a setup change is just a recipe for a slow, unpredictable car. Finally, let's put it all together and see how this actually works in the real world, from the moment the car rolls out of the garage to that final click on the laptop. It's a constant cycle that just repeats all weekend. The car does a run on track. The second it gets back to the garage, boom, you download the data, maybe with a USB stick or a cable. While that's happening, you're debriefing the driver, getting that fresh feedback. Then you analyze and overlay the data, make a decision, and finally, update the car's setup file. And then you do it all over again. And this screen right here, this is the end result of that whole process. Inside the setup software, the engineer makes the change, saves a new setup file, like this .s19v file, and it gets loaded directly into the car's brain. The loop, from an on-track problem to a data-driven solution, is now complete. So what should you take away from all this? A few key things. First, avoid changing too many things at once. Otherwise, you'll never know what actually worked. Second, and this is a big one, never trust feeling alone without data to back it up. And to make it really concrete, think about a track like Boreum with its massive straights. The data will tell you that everything comes down to your mid-corner minimum speed and a clean early throttle application. That's where all the lap time is hiding. So at the end of the day, the thing to remember is this. Data is the truth, feedback is the feeling. A great race engineer is the bridge that connects them. And that connection is what unlocks the ultimate lap time.